Hi friends, once again I'm here to share my views on topic security attacks. So about security attacks, I'm going to talk about some things like information security risk associated with the Universal Serial Bus USB storage devices have been serious issues since 2003, which marked the wide adoption of USB technologies in the computing industry, especially in corporate networks. Due to the insecure design and open standards of USB technologies, attackers have successfully exploited various vulnerabilities in USB protocols, USB embedded software, security software, USB drivers, and window autoplay features to launch various software attacks against host computers and the USB devices as well. The purpose of this paper are to provide an investigation on the currently identified USB-based software attacks on host computers and USB storage devices, to identify the technology and labors of the attacks and to form taxonomy of the attacks. The results show that the multi-layered security solution framework involving software implementations at the user mode layer in the operating system can help eliminate the root cause of the problem radically. And the framework for defending embedded system against software attacks, the incidence of malicious code and software vulnerability exploits embedded platforms in constantly on the rise. Yet, little effort is being devoted to combating such threats to embedded systems. Moreover, adapting security approaches designed for general purpose systems generally fails because of the limited processing capabilities of their embedded counterparts. In this work, we evaluate a malware and software vulnerability exploit defense framework for embedded systems. And the proposed framework extends our prior work, which defines two isolated execution environments, a testing environment where an untrusted application is first tested using dynamic binary instrumentation that is called DBI as well, and a real environment wherein a program is monitored at runtime using an extracted behavior model along with the continuous learning process. So we present a suite of software and hardware optimizations to reduce the overheads induced by the defense framework on embedded systems. Software optimization include the usage of static analysis complemented with DBI in the testing environment, that is called a hybrid software analysis approach. And hardware optimizations exploit parallel processing capabilities of multi-processor systems on the chip. We have evaluated the defense framework and proposed optimizations on the ARM Linux operating systems. Experiments demonstrate that our work achieves as high as coverage of considered security threats with acceptable performance penalties. Execution time of applications goes up to 1.6x considering all optimizations, which is more smaller than 2.72x. Performance penalty when no optimizations are used, and security is difficult to achieve on general purpose computing platform due to their complexity maybe or excess functionality and the resource sharing. An alternative is the creation of a tailored trustworthy space for the system or application class of interest. We focus on data-intensive computing systems using reconfigurable hardware to implement streaming operations and provide security assurances that are independent of application software, middleware, or operating system integrity and correctness. All interaction between software and data flow hardware passes through an automatically synthesized and formally verified hardware controller that incorporate enforcement and real-time monitoring of application using specific rules. And abstractions provided by the BlueSpec high-level language assist in the translation of domain-specific policy rules to synthesized logic ones. And for the cognitive radio example, used hardware enforced policies that includes physical layer rules such as sanctioned spectrum usage, and policy changes cause the secure generation and transfer of a new controller, a wrapped data path hardware plugin. And DataPath block swaps the operations are managed entirely by the hardware controller rather than software drivers. So I hope you like this video as well. Thank you for watching.